The deep dive is open. If you've spent any time at all in the world of 3D printing, especially FDM printing, you know the one big, messy problem.
Oh, yeah.
Filament waste.
It's the Achilles heel, isn't it?
That-
For color, for multi-material printing, every single time you want to switch from, say, red to blue, you have to flush out the old stuff.
And you get those purge towers, those blobs. It's just so inefficient.
It's incredibly wasteful, and honestly, it's been the biggest bottleneck for real productivity with these machines for years.
And this week, we are looking at the machine that claims to have, well, completely solved that problem. We're doing a deep dive into the Bambu Lab H2C and its really revolutionary new system, Vortec.
Yeah, this thing is really shaking up the high-end market. It's not just another model, it's a whole new philosophy. The H2C is, it's aiming for the throne of semi-professional printers.
A leap forward, you'd say.
A massive leap forward from their X1 series and the AMS. It's all about zero-waste efficiency and, frankly, incredible speed.
So our mission today is to give you the ultimate shortcut to understanding this shift. We're going to unpack the technical genius of Vortec, we'll analyze the speed gains, and then, and this is critical, we're diving into the very serious security concerns and how this machine addresses them. Let's get into it. So before we get to the zero waste magic, let's just set the stage. What is the H2C?
It's a prosumer workhorse, plain and simple. It's not a hobby machine.
Okay.
You've got the raw speed of a core XY system, but it's combined with a level of environmental control and, precision that you normally only see in industrial machines that cost 5, maybe 6 times more.
You can see that just looking at the spec sheet, can't you?
Oh, absolutely. The ambition is right there. Let's start with the build volume. It's a very comfortable 330 by 320 by 325 millimeters. That's solid. But where it really shows its intent is the thermal management.
And why is that so important for the kind of user this is aimed at?
Because serious materials need serious heat. The nozzle on the H2C can get up to 350 degrees Celsius. And that is absolutely crucial. That number means you can actually print the really demanding polymers. We're talking polycarbonates, high-temp nylons, PEI, stuff that would just clog or warp on a standard machine.
And I guess having a hot nozzle is useless if the rest of the environment isn't controlled.
Exactly. It has an actively heated chamber that gets up to 65 degrees Celsius. That controlled environment is what stops big parts from warping or layers from splitting. It's what separates a consumer toy from a real production tool.
And this being Bambu Lab, I'm assuming it's packed with smart tech.
Of course. It's got an AI camera and a new-gen LiDAR system. And they're not just for watching the print, they're for active error detection.
So it's trying to stop failures before they happen.
It's proofreading itself, basically, catching spaghetti failures, first-layer problems, all before it ruins a 30-hour print.
Okay, let's get to the practical stuff. Price and availability. This isn't something you can buy tomorrow, is it?
No, it's up for pre-order, with delivery slated for, late 2025. And the starting price is up there. You're looking at over 2,200 EUR.
So we should be really clear here. This is a serious investment.
It is. This is for print farm owners, small manufacturing businesses, or, the really demanding hobbyists where speed and efficiency directly translate to money or product quality. You're paying a premium for that industrial level efficiency.
Okay, so the hardware is serious. But the real story, the reason we're doing this deep dive, is how it solves that waste problem. Enter Vortec. Now, we've seen competitors, right, like the Prusa XL with its tool changer. How is Bambu's approach different?
It's all about miniaturization and minimizing moving mass. That is the fundamental difference.
So what does that mean in practice?
Well, the Vortec system exchanges only the hot end. Just the tiny part that melts the plastic.
Yeah.
The entire print head, with the extruder motor and all the heavy motion components, stays completely still.
And why is that such a big deal? Swapping a hot end versus a whole tool head.
It's all physics. It's inertia. On a fast Core XY printer, every single gram you have to accelerate and decelerate slows you down. A big, heavy tool changer carries a huge inertia penalty.
Right. It has to fight its own weight.
Precisely. Bambu Lab realized if they only swapped the tiny, lightweight hot end, they can keep those blistering printing speeds. They get multi-material capability without sacrificing motion speed.
That makes so much sense. Less weight, faster acceleration.
Yeah.
And that smaller mass must be why the swap itself is so fast. I saw a figure of 8 seconds for the nozzle to heat up.
8 seconds. It's incredible. That's thanks to induction heating.
So it's almost instant.
Almost. And it's all managed by this magazine system. It holds 6 of these interchangeable induction hot ends, plus you have the one standard hot end already in the head.
So that's 7 different materials or colors with WIS. And this is the headline: Zero purge waste.
Zero. No purge tower, no blobs, nothing.
That's the magic?
And think about the economics of that. It's not just about getting rid of the mess. On a complex multicolor print, you can waste, 20, maybe even 40% of your material in purging. So if you're using engineering filaments that cost 50 or 70 euros a kilo, eliminating that waste means this machine starts paying for itself surprisingly quickly.
And the raw numbers back that up. The test units showed a full filament swap takes about 25 to 28 seconds.
Right. And you compare that to their older system, the H2D with the AMS2 Pro, that took 80 seconds.
80?
80 seconds. Because it had to rewind the filament, purge, cut, load the new one. So on the H2C, you're saving almost a minute on every single material change. If a print has 1,000 color changes, you're saving hours.
I'm just fascinated by the mechanics of it. This little piece of hardware being picked up and dropped off automatically. How do they make that reliable?
It's a surprisingly simple and robust lock and load system. The print head has this little rod that engages a locking tab on the HOTEN.
Okay.
So to drop one off, the rod pulls the tab, the whole magazine row kind of pops up a tiny bit for clearance, and the HOTEN just drops into its cradle. Then it reverses to pick a new one up.
And it uses the printer's own motion system for alignment.
Exactly, and the induction heating is wireless, and the HOTEN itself actually has memory. It remembers the last filament it used. It's a very clever, very integrated system.
So let's talk about what this means for you, the user. The standard package comes with, 4.4 mil induction HOTENs plus the standard one and then a couple of other sizes.
Correct. So right out of the box, you get 5-color printing with no purging using the standard 0.4 millimeter nozzle size. Plus, you get a 0.2 and a 0.6 to experiment with.
And you can buy more to fill out the rack for the full 7?
You can. The ultimate set fills all 7 slots. And that's where the material versatility really shines. You can combine materials that just do not play well together, like a soluble support material like PVA in one nozzle and structural ABS in another, with zero risk of cross-contamination.
But the printer can actually handle more than 7 colors if you need it to, can it?
It can, yeah. Up to 24 colors or materials in a single print.
How does that work?
It uses a smart algorithm in the Bambu Studio slicer. So for swaps beyond the 7 nozzles on the rack, it does have to do a small purge. But the software is so intelligent about the order of the swaps that it minimizes that waste dramatically. It's really smart material management on a scale we just haven't seen before outside of, massive industrial machines.
Now, reliability is always the big quotient when you add complexity. More moving parts means more things that can break. I saw a report that a test unit did 30,000 swaps without an issue, which is impressive.
It is impressive.
But for a print farm running 24/7, isn't adding 6 extra nozzles just asking for more maintenance headaches?
That's a fair point. And yes, there is more complexity. But the design seems focused on being really robust and also fault tolerant.
What do you mean by that?
So if something does go wrong, like a little piece of cut filament gets stuck, the whole system just pauses. It gives you a clear alert and tells you exactly where the problem is so you can fix it without causing any real damage.
And for all that complexity, the whole system is surprisingly compact.
It's amazing, isn't it? The entire Vortex system, the rack, for all 6 HOTENs, it all fits inside the printer's frame, and it only eats up about 20 millimeters of the build plate. That's an incredibly small footprint for what it does.
Okay, final hurdle on performance. Precision. You've got 7 different nozzles printing on the same object. Any tiny misalignment would ruin the whole thing.
And that's all automated. The H2C has automatic nozzle offset calibration. The printer uses its own sensors to measure the exact position of every single HOTEN relative to the main one.
It does this on its own.
Completely automatically. It's dynamic, so it makes sure that when it switches from nozzle 3 to nozzle 6, the lines are perfectly aligned. It requires zero input from you.
Okay, this is where things move from just hardware innovation to, the real world. We have to talk about security. This machine is launching at a time when intelligence agencies are sounding some pretty serious alarms.
They really are. You have to bring up the warning from NUKIB, the Czech National Cyber and Information Security Agency. They raised very specific concerns about smart 3D printers of Chinese origin that rely on cloud services.
So for our listener, maybe someone working in R&D or prototyping, what's the actual risk here that NUKIB is flagging?
The risk is industrial espionage. It's intellectual property theft, plain and simple.
Right.
A lot of these smart printers, to give you that remote monitoring from your phone, they collect detailed telemetry data. And critically, they send the actual print files, the source G-code, the geometry to servers. Often those servers are in China.
So if you're an engineering firm printing a secret prototype, you're sending that digital blueprint through a third-party cloud.
Which is a massive, potentially catastrophic security leak.
That puts huge pressure on a manufacturer like Bambu Lab to offer real, verifiable security controls. It can't just be a checkbox in the software.
It has to be robust.
Yeah.
And the H2C's answer to this, its direct physical response, is a hardware switch for what they call stealth LAN mode.
A physical switch. Tell me how that changes the security posture for a user.
It's the ultimate control. When you flip that switch, you are physically disconnecting the Wi-Fi module from the external internet. The printer is then forced to communicate only within your local network, your company's secure LAN.
So if I'm printing that secret jet engine part, I flip the switch, and I have a guarantee that the file cannot leave my workshop and go to the cloud.
Precisely. You give up the convenience of checking your print from your phone while you're out, but you gain absolute confidence that your data is staying on-premise. It's not a true air-gapped system, but it's the closest thing on the market that still lets you use your local network. It shows they really understand their target market. For them, security is more important than connectivity.
So let's bring this all together for the listener. If we're summarizing the big advantages of the H2C, what are they?
Well, number one is obviously the efficiency, the ecology, and the savings from zero-waste printing.
Number 2 is speed. Not just the print speed, but the radically faster material swaps, saving you hours on complex jobs.
And third, I'd say it's that combination of material versatility, being able to cleanly combine difficult materials, and the security. The ability to physically lock down your IP with that stealth LAN mode.
And the downside.
The downsides are clear too. It's a complex system, which means more potential points of failure than a simple printer. And of course, that very high price tag. Over 2,200 EUR is not for casual use.
Right. It's a professional tool.
Definitely. But even if this specific machine isn't for you, it absolutely signals where high-end 3D printing is headed.
And speaking of the future, you mentioned how compact the Vortex system is, only eating up 20 millimeters of space. What does that suggest for their other printers?
It suggests scalability. The design is so compact that there's a lot of speculation that we could see this technology move down the product line, maybe a successor to the X1 and X2 perhaps, with a smaller 4-nozzle version of Vortex. It proves the tech isn't just for the flagship. So I think the core insight, the thing we really want you to take away from this, is that the whole philosophy of multi-material FDM is shifting. We're moving away from these big, heavy, slow tool changers.
Right.
The new formula, the future, is all about haute-end miniaturization and the incredible speed of induction heating. That's the new path to productivity.
Absolutely. And for you, the listener, if you're currently running a business with multicolor parts where you're just throwing away piles of expensive filament, this zero-waste approach could mean the return on investment for a machine like this is surprisingly fast.
Yeah.
You're turning waste directly into profit.
And that leaves us with a final provocative thought for you to consider. Given the very real security threats highlighted by agencies like NUKIB and the need for hardware solutions like stealth LAN mode, how will our expectations as users change? Will we start demanding these hardware-level security measures on all smart manufacturing devices, not just the professional ones, forcing manufacturers to choose between the convenience of the cloud and the absolute security of our data? That balancing act, I think, is going to define the next generation of every connected device in this space.